Bismillahirrahmanirrahim. Noether Symmetry equation, Noether theorem. So we are going to derive Noether Symmetry equation in this video. This equation is very important for mathematical physics or applied mathematics. This equation in use in many fields. Relativity, we use it in relativity, find the Noether symmetries of the space-time and the conservation laws. So it's deeply connected with the Lagrangian formalism. So Noether symmetry is the symmetry in which the action of the given dynamical system remain invariant. So let's start. This is the action, or this is the Lagrangian density, and the action is defined in this equation. Lagrangian density depend on time, coordinate and velocity, and it is density, so it is integrated on the whole time interval to get the action of the given dynamical system. This is the Noether symmetry transformation or infinitesimal transformation. T star equal to T plus epsilon xi and Q star is equal to Q plus epsilon eta, and this is the corresponding generator. You people know that xi is equal to dt star d epsilon. So what is this? This is xi, and when you differentiate it, then put the epsilon equal to 0. Similarly, you see symmetry method, people know that eta is dq d epsilon, and then epsilon is 0. So these things, symmetry method, student know it. So this is the generator, this is the transformation, is called group transformation, and this is the algebra generator. The velocity transformation. So to find the velocity transformation, we take dq. So this is q star, so this is dq star dq epsilon d eta, and dt star dt plus epsilon d xi. You see it on the previous slide. Take the differential on this and the differential on this, we get these two equations. Now putting over here, this is dq I mean many dependent variable, plus epsilon d eta I. Eta I mean many etas for each dependent. dt plus epsilon dxi. So it can be written dqi plus so I can do it dt plus epsilon d eta I dt and dt over dt. So I divide this by 1 over dt and the denominator also dt. So in fact what I did, I multiply this with 1 over dt, also this one with 1 over dt, so they cancelling. So here we get q I dot plus I am writing this epsilon d eta. So this is the operator d by dt, and this is 1 epsilon d xi. So q star dot is equal to, so this is velocity transform. We are interested in the velocity transformation, infinitesimal transformation, velocity infinitesimal transformation. So we can write it q dot I epsilon d eta I, and it is multiplied with 1 minus, okay, let me write it as power. So I write this as 1 plus dxi minus 1. So using the binomial theorem, this is dot epsilon d eta I, and this is 1 minus d xi using binomial theorem and the first two terms, considering first two terms. Now multiply, we will get qi dot and then epsilon d eta. So I am taking epsilon common because it will be in two terms. So the first term is multiply the 1 with the second term, so that is d eta I, and this one with this one, so there is minus sign, q dot I d xi, and when I multiply, I think I left with epsilon over here. This is, here is the epsilon, here is the epsilon, and here is the epsilon, so that is okay. Now epsilon is common. Now when I multiply the last term with this last one, that is epsilon square, and we ignoring epsilon square, where epsilon is very small parameter. So this is the velocity transformation written on the next slide. You see this, I do the whole calculation, but the detail is here. We derive this in the previous slide. Q dot I star equal to Q dot I plus epsilon d eta I. So dt is in fact d, I write it d, you can write it dt, mean the differential of t, whole differential with respect to t. So this formula is written over here, this one. So that is the velocity infinitesimal transformation. So in the bracket, inside the bracket, this term is the extension. This is eta 1. This is the extension, and this is equal to variation in velocity. This is variation in velocity term, eta 1, variation in velocity. We will explain this a little bit later, this equation. Okay, so the first extension of the Noether symmetry generator is this. And in expanded form, this is the generator and this is the first prolongation term. So this is the first order extended generator, and why we need it? Because the Lagrangian depend t q and the velocity q dot. If there are many dependent variables, so there will be I. So the Lagrangian depend on the velocity, so we have to extend the generator up to the first derivative term, the first eta 1, because our Lagrangian depend on the velocity. Okay, now this is action after transformation. Before transformation, we write it, this action is equal to S is equal to Lagrangian T Q I Q dot I and dt. This was before transformation action of the dynamical system. After transformation, this is the action of the dynamical transformation, dynamical system. So how this equation is derived? Let's do it. The Lagrangian of T star Q star and Q dot star is equal to Lagrangian of T Q and Q dot and change in the Lagrangian delta L of T TQ and Q dot. So you see this is L, and the change in the Lagrangian occur due to T, Q and Q dot. So that is partial L partial T delta T, partial L partial Q delta Q, and partial L partial Q dot delta Q dot. So that is change occur in the Lagrangian, that is variation the Lagrangian. Okay, Now we see from the previous slides that Q star is T star is T plus epsilon xi. So T star minus T is equal to epsilon xi. So that is the variation in T. Similarly, variation in Q is equal to epsilon eta. Variation in Q, this is Q, and variation in Q dot is equal to epsilon eta 1. Oh, that one is putting this value over here. You see L value of delta T is epsilon, so here is plus sign, epsilon xi partial L partial T plus value of delta Q is epsilon eta partial L partial Q, and delta Q, that is epsilon eta 1 partial over partial Q dot. So taking epsilon common, we get the given result, epsilon common. So what we get, partial by partial T xi partial by partial T plus eta partial by partial Q plus eta 1 partial by partial Q dot operate on L. So this is exactly epsilon, this is one time extended generator over L. This is this equation. So this is L star, so this value, we find the value of this in term of the Lagrangian. So this Lagrangian under after transformation is actual Lagrangian plus the variation in the Lagrangian. Now this A star can be written this way, A star is equal to integral L plus epsilon x1 time extended over L and dt. This is the form of this, but with epsilon. Now this is, we see that T star is equal to T plus epsilon xi. So operate the d dt star equal to dt plus epsilon dxi, and take the dt common from here, that is epsilon dxi dt, and that is exactly this thing, this is 1 plus epsilon dxi, which is written over here, and dt, I take it common. This is T star. Okay, star was this integral L star dt star. So putting the L star from the previous and dt star from here, this was you see this is L star. So L star okay. Okay, so this is L star up to here and this is dt star. So from there we can have these three terms. You see that L plus so this multiplied with dt star, so that is 1 plus epsilon dxi and dt. So from here we can get these three terms, L multiplied with 1, that is L. Then this term is multiplied with 1, so that is epsilon x1 L. And this term multiplied with the L, so that is epsilon L dt xi. And when we multiply the epsilon term with this epsilon, that is epsilon square, so we ignore that. So we have only these three terms after transformation. Now how this equation is derived, that is in fact difference between S and S star. So S is LDT and let me correct it. This is I'm calculating delta S, which is equal to star first and then S. So star is this, that is integral L. So I am writing separately LDT, the first term, and the epsilon term I will write in one integral, taking epsilon common, these two. So here is x1 L plus L dxi and dt, and then this S is equal to minus S LD LDT. So this cancel with this one. So this delta S variation is this, and we calculate it over here, that is the value. Now this variation in S is at most a divergent term. I write that D, that is D with epsilon dA dt. So this is delta S. It is at most a divergence term or constant of integration. You see, this A is gauge function. A is called gauge function. Is equal to epsilon integral x1 L plus L dxi and dt. Now comparing these two, the epsilon will cancel with the epsilon, integral with the integral, or another word we have to write in one integral. This total can be written as this. Integral, I am writing epsilon is a constant, so inside write first these two, x1 L plus L Lagrangian dxi and minus this dA and whole dt, n is equal to 0. So this integral is 0. Now this epsilon is arbitrary. This epsilon is arbitrary. And the integral is 0. That implies that the value in the bracket is 0. That is x1 L plus L dxi and minus dA equal to 0. So that is x1 L dxi. This d is total differential operator. d by dt, we see it earlier, is equal to dA. This is Noether symmetry equation, and we write it on the slide after it. This is Noether symmetry equation. So the divergence term is, you see over here, this one, this is another symmetry equation, and the main purpose of this lecture was to derive this equation. The purpose of this lecture was to derive this equation. This is written in many books in this form, and in this video we derive it step by step. Okay, if this video is helpful, then like comments for improvements and subscribe for help. Okay, thank you.